Okay, welcome to this short video on how to use Imaris and the Cell module. So to start, we need to add some datasets into Imaris, and in order to do that, you have to be in the arena view here and select Observe a folder. When you do this, you can select a folder from your computer. Here it's called Folder to Watch. Select it, and you can see that it has already added all the images contained into this folder. When you have a look at these images, you can see that those are CZI files coming from a Zeiss confocal microscope. And in order for Imaris to work on them efficiently, you need to convert them. So to do that, just double click on the file, and you can see here there is some conversions going on, and now you can see that the file is now something .ims, which means that it has been converted. Now we can open it into the Surpass module by just double clicking on it. So this is the 3D viewer of Imaris here, and you can view your dataset by rotating the dataset using the left mouse click, keep it pressed, and if you use the right mouse click and keep it pressed, you can pan, and if you use the mouse wheel, you can zoom in and zoom out. You can also enable or disable some channels here by using the display adjustment tab, which you can close and you can bring back by going to edit, show display adjustments. You can also change the colors of the channels by clicking just on the name of the channel itself and choose another color like this. So let's go back to something close to the original. Okay, so now we have to add the cell module here. But before we do that, a good idea might be to make sure that you are working at the correct resolution. Because, for instance, this file is probably too big to be processed quickly. So I can go here to Edit, Resample 3D, and as you can see, it's 2000 by 2000 pixels in the XY direction, and we can easily cut this down to 512 by 512. So as you can see, the aspect and the representation of your dataset doesn't change that much here, but it will do a nice improvement in the speed of the calculation. So let's add our cell component here. And now we have to decide what kind of cell detection we want. So I will use the middle one here, detect nucleus and cell, since we are not interested in vesicles, and we will process the whole region, the whole image, sorry, but we could limit ourselves on a specific region if needed. So let's proceed to the next step, and here we have to specify the diameter of a nucleus. So to do that, we can switch to the slice view here, which allows us to display the individual slices here, and maybe we can just also switch off the channels which we are not interested in. And as you can see, we can click 2 points into the image and we will have a readout here of the distance. So this diameter corresponds to around 8 microns, but usually for a good detection I prefer to look for the smallest diameter, so around 5 microns here. So let's switch back to 3D view, and enter this value, so around 5 microns here. It's also a good idea if you have several objects inside the same channel then to use this split nuclei by seed points option. So it will allow us to make sure that those seed points will be used and can restrict the detection to really what we want. So by going to the next step here, we can decide to filter those points by including cells which have a quality threshold in large enough to be included, and maybe we can add another filter to exclude nuclei or objects that are looking like nuclei which are at the periphery of the image. So we can just click here to add, and from this drop down menu here we can choose distance to image border here, and so this is already the right setting. We can see here by playing with this value, with this threshold, that you can restrict the detection to those 2 points. And now we will proceed here to the next step, which is a real intensity threshold to really describe correctly the shape of those nuclei. So in order to visualize this, here we have now an orthogonal slicer, and by clicking and dragging into the image you can change the plane level here, but we can also view this as a volume by going to settings here and change it to volume display instead. So here we have now a 3D view of our object, and sometimes it's a bit better to make sure the detection is really corresponding to what we want. So here we can adjust a bit more the thresholds to something, let's say like this. Then we can proceed to the next step. So now we have detected correctly our 2 nuclei. Here we can still do some filtering if needed. At this step it's not necessary, so we can proceed now to the cell detection. So again, here we can decide on which channel to work, and we have also to decide if we want to use detection by cell boundary from cytoplasm signal or cell boundary from cell membrane. So if we switch off those detected nuclei for an instance, for a moment here, and if we enable the green channel, the image looks like this. So I think this is way better as a starting point than the membrane signal here in red, because this is quite messy, and I think the algorithm will have a really hard time to describe an object within those membranes. So we can enable just a green channel, enable back the cells, and now we will work here with this detection mode. If needed, we can also do a detection with the cell membrane to just see the difference. So here I will let those parameters by default for the moment, and I will also not do any background subtraction, since the green signal is is made of dots, and you might enhance the contrast instead of making sure everything is homogeneous, which is needed for the algorithm to work correctly. So just leave this out. Let's proceed to the next step here, and again this is a threshold to restrict to the area of the cell this time. So I think something like this might cover the right region. And here we have additional options Since we have two cells who are touching each other, we can separate them by making sure that there is only one nucleus per cell. And we want also to make sure that this expand cell or nuclei option is checked correctly here. If you're interested into the details, I encourage you to watch the very nicely done Imaris tutorials. They explain this in detail. So let's proceed to the next step here. And here we can see that the detection has been done correctly. Let's say it has detected multiple objects, and now we have to filter out those which are not the cells we are looking for. So here, instead of cell number of voxels, this is a filter by size. We might instead, since we have already done the detection of nuclei, use the number of nuclei here to discriminate between the cells we want and those we don't want. So by doing this here, we keep only the cells which have at least one nucleus. So actually those two cells here. And with this we can finish our processing, and now we have our two cells here and our two nuclei components. We can change the display here by going to the color tab, and for each type of objects we can change the display type. So for instance, if we want to render the cells transparent and change their color to maybe something like I don't know, a homogeneous color, here we can do this. And for the nuclei we can also change the color, let's say by statistics. So for instance, which one of the cells have the bigger volume, something like this. Okay, and if you want more statistics, you can click on this statistics tab here, and this will describe statistics per cell, but you can also see average values here, so for all the objects detected here. And if you are interested in a specific object here, for instance, if I select this nucleus here, I can go to the selection and here choose any statistics I want. If I want to measure something and it's not currently listed into this list, I can look for it here by configuring the list of visible statistics values. If I click here, you can see that I have a huge list of different values, and I just need to enable them. So if I'm interested in, I don't know, if I want to the cell intensity sum for some reason, I can just check this, and now I should have here, yeah, the sum for each of the channels available. So once you have configured the statistics you want, you can export them using the diskette button here, export statistics, or if you want all of them, you can use this tool to do this. So once you're done, you can go back to the Arena module and save the changes here. Now, what if we want to do the same processing to another data set here? There is a simple trick to do here. If we go back to our previous file here, and you can see it has saved all our transformations, we can, by selecting the cells object here, we can go to the wand here and we can recalculate everything, but we can also store the parameters. So if we click here on store parameters, we can give it a meaningful name, let's say cell segmentation 1, something like this. Press OK. Go back to the Arena, save our changes, and now you can see here we have a new file which is which contains all the parameters for the analysis we did. So let's convert and open a new image here. Let's resample it like this and add a new cells object. And here, instead of going through all the steps, we can just choose from this drop-down menu cell segmentation 1 here, okay, and just go through all the steps automatically. So if the data sets are quite similar, you will get similar results. If not, you might have to tweak several steps. And for instance, here we can go back by using the one tool again and recompute. And now we can process each step separately. So let's see here if this is still working okay. Yes, we still are detecting only the two nuclei that we are interested in. Those levels seems okay. So the nucleus part seems to be working correctly. Now for the cell detection part, this is maybe something you will have to tweak. And here, for instance, I can also decide to change from the detection from the cytoplasm to the membrane. Just that make sure here that we are selecting the right source channel here. And for those parameters, again, we have to look at the slice tool here. So I will uncheck the channels I don't need, go back to slice here. And the system asks us for cell smallest diameter and membrane detail. So the smallest diameter will be something like this here. So 4 micron, because the cell will be this dark area here. And the cell detail is actually the thickness of the membrane, so 0.5, something like this. So let's go back here. So 5 micron and 0.5. So it's doing some processing here. And again, here there is already a filter, cell number of nuclei above 1, 2 of 2 selected. So those are the 2 cells. And we have again the view from the orthogonal slicer. I like better the volume display here. So this is the area that is now selected using the membrane instead of the cytoplasm. We have no more parameters to work with, so as you can see, it's maybe less ideal than using the green signal here. If we are still satisfied, you can finish here and get the statistics as previously here. So this is it for this video. I hope it has helped you to understand how to use this module. And if you have any more questions, don't hesitate to write to me. I am Yannick Krempp. I am working at the CIF platform at the Lausanne University. Bye bye.